In this video, we will focus on parallel computing. But before that, let's understand why there was a need for parallel computing. So in olden days, the computer softwares were specifically designed for serial computations. In serial computing, an algorithm divides the problem into smaller instructions. These instructions are then executed on the central processing unit of a computer one by one. This was creating a huge problem in computer industry as only one instruction was getting executed at the moment. Additionally, the required amount of time for executing multiple instructions was also high. Thus, to overcome the issue of serial computing, the parallel computing comes into the picture. The parallel computing is the use of multiple processing elements simultaneously for solving a problem. Initially, the problems are broken down into instructions and are solved concurrently. Advantages of parallel computing over serial computing. The parallel computing saves time and resources, as many resources working together will speed up the execution. The parallel computing can solve larger and complex problems. The serial computing does not use the potential computing power of the CPU, but parallel computing does. Now let's look towards the types of parallelism. Number 1. Bit level parallelism. The bit level parallelism is based on an increasing processor size. It reduces the number of instructions in order to perform a task on large size data. For example, consider a scenario where an 8-bit processor have to complete operation on two 16-bit integers. Initially, it have to sum the 8 lower order bits first and then add 8 higher order bits. Thus, it requires two instructions to perform the operation, whereas the 16-bit processor can perform the entire operation with just one instruction. Number 2. Instruction level parallelism. Since the processor can only address less than one instruction for each unit of time, these instructions can be reordered and grouped, which are later executed concurrently without affecting the output of the program. This is called the instruction level parallelism. Number 3. Task parallelism. In task parallelism, a task or process is decomposed into multiple subtasks and then allocating each of these subtasks for execution. Here the processor performs the execution of subtasks concurrently. Number 4. Data level parallelism. It is an approach to computer processing that aims to increase the data accessibility by operating on multiple portions of data simultaneously. For example, consider two CPUs A and B in parallel environment and let D be the dataset. Then it is possible to tell CPU A to do the task on one part of D and CPU B to do the task on another part simultaneously. The data level parallelism is limited by non-regular data manipulation patterns and by memory bandwidth. Applications of parallel computing, databases and data mining. A data mining is a process for finding trends or patterns in the data. Real-time simulation of systems. Science and engineering. Advanced graphics and virtual reality. Future of parallel computing. The future of parallel computing involves continued advancement in technology and software development. This includes the development of programming languages, frameworks, and tools to make it easier for the developers to write parallel programs. The tech giants such as Radeon, Intel has already taken steps towards parallel computing by implementing multi-core processors. For the upcoming